Good day, my dear students, and welcome back here again in our science class. And for today's topic, I'll be discussing balancing chemical equations. So, for our first objective, you must be able to balance a chemical equation using the number of atoms in the reactants and products through a solving. Second, you must explain the importance of balancing chemical equation through application in real-life situation. So, first, let us define what do you mean by chemical equation. So when you say chemical equation, it describes a chemical change when a certain reactant has a changes in the product. For example, when you put a water on the freezer, then definitely it will go under a chemical change when the water or the liquid turns into a solid. Okay? Now, under the chemical equation, we have also the parts of it. So this yellow, as you can see here, this is what we call the chemical equation. So the label of here, first on the left side, we have the reactant. Then on the right side, we have the product. And the arrow in the middle, we call it as the reaction symbol. As a symbol, literally, to shows that a certain equation in the reactant undergoes a reaction. So again, when you say reactants, the chemical you start with before the reactions, and usually written left side of equation. For the product, the new chemicals formed by the reaction, which is also written on the right side of the equation. For the subscript and coefficient, we are referring here that first subscripts show how many atoms of an element are in a molecule. For example, H2O. So the subscript here is what we're talking about is here. Means that 2 atoms of hydrogen. And when you say oxygen, you see there's no number, right? Always remember, then 1 atom of oxygen, that's an indivisible one. Okay? So usually this 1 atom or 1, we don't usually write anymore. For the coefficient, shows how many molecules there are of a particular chemical. For example, we have 3H2O. The coefficient here is here. Means there are 3 water molecules. To further understand this concept, let's try to analyze this animation. So you can see our chemical formula or equation, we have 2H2 plus O2 produces 2H2O. So if you're going to look for this or observe this animation rather, it formed 2 water molecules. In balancing chemical formula, they also follow rules and law, such as law of conservation of mass, where that the chemical reaction matter is neither created nor destroyed. In other words, the number and type of atoms going into reaction must be the same as the number and type of atoms coming out. And if an equation obeys the law of conservation, it is balanced. What this trying to say is, kung ano yung nandun sa reactant mo, dapat pareha siya sa product. What goes in must be the same when it goes out. Now, the rules in balancing chemical equation, first, you must remember and take note that matter cannot be created or destroyed. Subscript cannot be added, removed, or changed. You can only change coefficients. Coefficients can only go in front of chemical formulas and never in the middle of a formula. For extra tips, try balancing big formula first and save free elements for last. There is no one particular way to balance equations, and some equations are harder to balance than others and might require some creativity to solve. So definitely there is no distinct technique or ways how to solve a certain balancing chemical equation. But in this video, I have a certain technique, still I have a technique for a beginner, for a guide. Okay? Let's try this one. So we have here CH4 plus O2 yields to produce CO2 plus H2O. So this is our equation. Okay? Now, for you able to understand what is written below, definitely, the technique that I will be teaching you as a beginner, the ladder type. So first, you create a ladder. So you put a line here, okay, and then you label a reactant, and then the product. So again, this is our reactant and this is our product. Now next, list down all the elements that is presented. So we have carbon, we have hydrogen, and we have oxygen for the reactant. Next, on the product, we have here carbon, hydrogen, and the oxygen. Next, you're going to look for their subscript. Since carbon here in our reactant side, there is no visible number, therefore we assume that carbon has a 1 atom. For hydrogen, we have 4, so definitely just simply looking on the subscript. And for our oxygen here, it has a 2. On the other side, carbon, again, we have 1. For hydrogen, we got 2. And then for the oxygen, you see here in our subscript here, we have 2. Okay? These 2 will be added on the indivisible 1 here of the oxygen. So 2 plus 1, definitely we have 3. Okay? Now, as you can see here, they are not balanced. Except for carbon, we have 1 and 1, and then for hydrogen, we got 4 and 2, which is not balanced, and oxygen, we got 2 and 3. Okay? So, for this type, for us able to get the balance here, we can put 2. Start tayo ng 2 dito. Lagay tayo ng 2. So, what I just wrote here is the coefficient. Never put the coefficient at the middle. For example, sa gitna ng carbon at hydrogen, maglalagay ka dyan ng 2. That will be marked as wrong. Only in front. Dito lang po. Sa harapan natin, no? Sa harapan na ng chemical formula. Yan. Okay? Now, so, the next process here is we're going to multiply. So, 2 times 2, definitely that will be 4. 2 times 2, that will be 4. Okay? So, since we put 2 here, what we can do here is we also put 2 here in the H2O. So, when you do that, okay, so 2 times 1, that will be 2, right? That will be 2. 2 plus 2, that will be 4. So, erase na natin to. We put it 4 here. Or let's say, for you not be confused, so again, 2 times 1, times 1, that is 2, and then we added 2, another 2, or subscript 2 of the oxygen, and definitely we got 4. So our oxygen here already balanced. The problem now is, since our hydrogen here is 4, definitely, if we multiply 2, okay, the 2 here, the coefficient 2 here to hydrogen, on the subscript of hydrogen na 2 also, definitely, this will give us also a 4. As you can see here, we have already the balance equation. So, carbon, 1, 1, hydrogen, we got 4, and then 4, and then oxygen, we got also 4, and yes, on the product side is also 4. So this is the ladder type that I'm talking about, na mabilis nyo siyang maintindihan or makikita nyo yung pagkakaiba agad ng reactant at saka ng product. Okay? So yes, we get the correct answer. So let's try to balance this equation. So first, write the equation. So we have the iron plus O2 yields to produce Fe or iron 2 3. Okay. So there we write again the ladder reactant product. Next, label the following elements. We have here the iron and we have the oxygen. On the product side, we have also a iron and the oxygen. So here, since we have indivisible 1, so iron has a 1 atom, oxygen has a 2 atoms. For iron, we have 2 atoms. And then for the oxygen, here we have 3 atoms. So as you can see here, they're not totally balanced. As you can see in the product, we have 2. On the reactant side, we have 1, oxygen 2, and then oxygen in the product side is 3. So what we can do here again is a matter of trial and error. For example, I can focus here on the product. So I can write here 2. So when you multiply 2 times 2, that will be 4. And then you multiply here again 2 times 3, that will be 6. So on the reactant side, it will be now easy for us to distinct. So we can write here 4. So 4 times 1, that will be 4. And then just simply again think of a number that when you multiply it will become the same as the product side. Okay? So we can put here 3. So when you multiply that, 3 times 2, that will be 6. So there we have already balanced equation. Let's try this again. So first again, I'll be writing the chemical formula. So we have nitrogen 2, dinitrogen plus dihydrogen yields to produce NH3. Okay? So ladder type ulit tayo. We have the reactant and the product. So we have here nitrogen and then hydrogen. And then on the product side, we have also nitrogen and then hydrogen. So the atoms that present in the nitrogen has a 2 atoms and the hydrogen has a 2 atoms. On the other side, we have 1 atom of nitrogen and 3 atoms of hydrogen. So there, was able to get balance on the reactant side. So we get put 2 here. We need to put 2 here. So when you multiply that, that will be 2. Next, if we're going to distribute that, 2 times 3, that will be 6. So here, we can write here in the dihydrogen 3. So that when you multiply it by 3, it will be also give you a same number of 6. So there we have already a balanced equation. Okay, now you will be asking that it has a number 1 in the end too. So it is not necessary to put 1 here anymore since it is indivisible 1, so no need for you to write that 1. Let's try this one again. I'll be writing again the chemical equation. We have the P of phosphorus plus O2 yields to produce P2O5. Ladder type again. Reactant. Product. Let us all put the chemical formula or the chemical symbol in each side. So in the reactant, we have the phosphorus and then the oxygen. The other side, we have the phosphorus and oxygen. So here, the atoms on the phosphorus is 1. The atoms here in the oxygen is 2. For the phosphorus, we got 2. And then the oxygen, we got 5 atoms. Wow. This one's kind of big. Okay. So, since the product here has a 2 and the phosphorus is 1, so what we can do here is we can write 2. So on this part, this will become 4, and then when you multiply again this one, 2 times 5, that will be 10. Okay, so since our phosphorus become 4, definitely we can now put 4 here just to make it balance. So it become 4. So this, to make it 10, we can write here 5. Okay, so we have now here the balance equation. Now, you may be wondering why I'm starting in the product, not in the reactant. So, actually, it's a matter of trial and error, but this will literally takes you a very long time, okay? It really takes up your time when you do each, okay? So, again, try to analyze where you can start putting a coefficient so that when you multiply it, it will compensate to another side. So, it doesn't matter where you start. It's either from the reactant or the product. Okay, it might be confused to you that, okay, I'll be starting balance first the product before the reactant, because there will be other cases that you need to focus on the reactant for a while, then go to the product. Okay, so we have the 4, 5, 2. Now, will we go using the ladder technique? So, reactant, by labeling reactant, product, so we write here the silver, oxygen, silver, and then oxygen. So the atoms here in the silver is 2. The oxygen, the atoms is 1. On the other side, we have 1, and then we have 2. So what we can do here is analyze again the chemical formula, and where do you think you should start putting it? So we can write here 2. So when you multiply that, that will be 2 times 2, it will become 4. So definitely in here in the product, we write here 4, so that when you multiply it, it will become 4. So we have the balance already. Since our oxygen here is 2, so when you multiply this 2 on this indivisible 1 or the atom, so 1 times 2, that will be 2. So as you can see here, I focus on the reactant rather than in the product. So there, you got already the balance equation. And for the last example, let's try this again. So it's kind of complicated. So again, we're at here, the chemical equation. We have the C2H6 plus O2 yields to produce CO2 plus H2O. So we label reactant and product. List down all the chemical symbols. We have the carbon, hydrogen, oxygen. Also on this side, carbon, hydrogen, and oxygen. Okay, so how many atoms do we have here in carbon? We got 2, and then for hydrogen we got 6, and then oxygen we got 2. On the other side, the carbon has a 1, oxygen has a, again, this is 3, and then hydrogen is 2. Now, I'll give you a minute. So this is kind of tricky one. I'll give you a minute for you to answer this, and later on I'll be giving the correct answer. Okay, if you're going to observe, this kind of complex. So when you do a trial and error, this will give you literally a confused answer or mixed numbers. Okay, so our carbon here is not balanced. You got 2 and then we got 1. So when you put 2 here, this is a possibility. So when you do a trial and error, if you put 2 here, definitely yes, it will become 2. However, when you multiply this one, it will become 4 and 5. So when it becomes 5, it will be difficult for you when the number become odds. So it should be an even. So the best thing you can do here again, so let's erase this. Analyze very carefully. Okay. So what you can do here is first, you write 2 here. So when you multiply that, 2 times 2, that will be 4. Since carbon become 4, definitely in the product side, you write 4 here. So 1 times 4, it will become 4. Next here is we distribute. So again, we got already 2 times 2, that is 4. Okay, 2 times 2, that will be 4. And then 2 times 6. So we write here 2 times 6, that will be 12. Since our carbon and hydrogen changes, so in the coefficient here, for us able to get a 12 atoms of hydrogen, so we put 6 here. So 6 times 2, that will be 12. Now for the oxygen, it will be now easy because when you multiply it, so 4 times 2, that will be 8, plus, okay, this one, 6 times 1, that will be 6, right? So 8 plus 6, that will be total of 14. Okay, so allow me to write it down here. So we got 8 plus 6, that will be 14. So we can write here on the oxygen 2 on the reactant side is 7. So you multiply it by 7, then that will be 14. So there, you have already the balance equation of this complex chemical equation. if we're going to apply this in a science concept, yes, it is very, very important to use balance, because this could give an effect when you're going to create a certain chemical product. Okay? Because if it is not in balance, it can be radioactive, it can be hazardous, or you may produce a chemical that has a very risk on people. And with that, I would like to thank you for attending this session, and see you on the next.